Today's lab involves the identification of aldehydes and ketones.
The first reaction is the 2,4-dinitrophenylhydrazine derivative formation involving the reaction between aldehyde or ketone and 2,4-dinitrophenylhydrazine. The derivative that is formed is called 2,4-dinitrophenylhydrazone.
Unknown compounds can be reacted with various reagents to form compounds called derivatives. Stable crystalline derivatives can be used to help identify unknowns by comparing derivative melting point with literature values.
Now let's look at the 2,4-DMP derivative mechanism. We have our ketone, which becomes protonated, and the 2,4-DMP lone pair of the nitrogen attacks the partially positive carbonyl carbon. And something to note is that these lone pairs cannot attack because this is actually part of the pi system of the benzene ring here. So you get this product, and the water molecule attacks that proton to get this product, and the hydroxyl group now grabs a proton to become a leaving group, and so that group leaves, and this proton becomes deprotonated to form our hydrazone product.
The next test we will be taking a look at is Toll's test. In this test, we have a reaction between an aldehyde along with silver nitrate and ammonium hydroxide to give us our carboxylate ion as well as silver, which can be observed in the form of a silver precipitate. When tested with the ketone, the silver nitrate and ammonium hydroxide yields no reaction. The next test we will be taking a look at is the chromic acid test. In this test, we have a reduction from chromium 6 to chromium 3. In the reaction of the aldehyde being oxidized to carboxylic group, this occurs within 15 seconds. The reaction involving the chromic acid with the ketone yields no reaction within minutes. The last test we will be taking a look at is the iodoform test. In this test, we have methyl ketone reacting with iodine and sodium hydroxide to yield sodium carboxylate and iodoform. Iodoform will be observed in a yellow precipitate. Other ketones, not just methyl ketone, will also react and lose the color of iodine. However, no yellow precipitate will be observed.
Now let's look at the iodoform test mechanism. This is our methyl ketone, which becomes deprotonated, and these two are the resonance structures. And then it goes through nucleophilic addition of iodine, and in this product, the two protons are even more acidic than it was before, so the reaction won't stop here, and it'll go through the same deprotonation and nucleophilic addition to get this product. And now this proton is even more acidic than these two protons before, and then it goes through the same process, deprotonation and the nucleophilic addition of iodine to get this. The hydroxyl group attacks the partially positive carbonyl carbon so that this group will be kicked off, and that group needed 3 halogens to be a good leaving group. And so there's the leaving group, which deprotonates, and that yields our yellow solid.
Here is an example of a flowchart which can be used to help us differentiate between our unknown aldehydes or ketones. As you can see, there are 4 example molecules shown. Molecule A, 3-pentanone, molecule B, propanol, molecule C, 2-propanol, and molecule D, 2-propanone. Alright, so let's take a look at the chromic acid test. From this test, we can differentiate a positive result, giving us either molecule B or C as our unknown, and a negative result, meaning we have A or D as our unknown. To further differentiate between molecules B and C, Toll's test can be performed. If a negative result occurs, it is likely molecule C. If a positive result occurs, it is likely molecule B. Likewise, to differentiate between molecules A and D, the iodoform test can be performed. From this, we can see that a negative result would indicate molecule A as our unknown, and a positive result would indicate molecule D as our unknown.